Solutions, page 174. So what we're going to take a look at is how water actually dissolves or pulls a solute into solution. There are two basic methods. The first method is when water pulls the solute into solution by forming ions. So the type of solutes that are pulled into solution forming ions, great examples would be an ionic compound, anything referred to as a salt, any type of acid, and bases. So my description gets a little bit graphic here, but what water does to the solute, the water, I say, decapitates the solute or dismembers the solute into individual ions. So the water pulls the particle, the solute, apart into separate ions. So take a look at the illustration. Water, as you know, H2O, is a very polar molecule, asymmetrical shape, large ENV difference between hydrogen and oxygen. So opposite sides of the molecules have polar differences. The oxygen side of the water molecule always carries a partial negative charge, and the hydrogen sides always carry a partial positive charge. When you take a salt or an ionic compound like NaCl and dump it into water, what happens is that polar negative side of the water molecule, the oxygen side, goes and starts pulling sodium ions, the cations, away from the crystal lattice. The polar positive side of the water molecule, the hydrogen side, goes after the anions and starts pulling the chloride ions away from the crystal lattice of the salt. So the net ionic equation is that you start off with NaCl in the solid phase, dump it into water, water dismembers or decapitates those ionic particles into individual ions. So on the product side, we see the cation of sodium separated from the chloride. This type of dissolving process, the attraction type, is referred to as an ion molecule attraction. The ions of the solute are attracted to the molecules of water, so ion molecule attraction. Take a look at this picture of the dismemberment of the solid crystal lattice. The solid crystal lattice has positive sodium ions alternating in position with negatively charged chloride ions. And as the picture shows, the polar positive side of water, the hydrogens, are surrounding and pulling the chloride anions away from the solid crystal. And the polar negative side of the water, the oxygens, go after and pull the cations, the sodiums, away from the crystal lattice, keeping the sodium ions and the chloride ions separated from each other. They are buffered with water molecules in between them. Let's take a look at the second method that water uses to dissolve solutes. So water uses its second method by overcoming or overpowering the intermolecular attractions or forces between the solute particles. So the type of solutes that water dissolves or pulls into solution using method 2 are polar molecules like sugars or alcohols. So once again, I have a little saying. So by overcoming the intermolecular attractions, water conquers and divides the molecules. So water, in this case, it pulls whole molecules away from each other. It separates molecule of the solute from other molecules in the solute. Once again, recapping water, very polar molecule, asymmetrical shape, very large END difference between the hydrogen and oxygen. The oxygen side always carries that partial negative charge, and the hydrogen sides of the molecule always carry a partial positive side. So you take a sugar like sucrose and you dump it into the water. Each individual molecule of glucose remains intact, but the polar negative side of water goes and pulls on a glucose molecule and yanks it away from the sample, and then the polar positive side of water goes and pulls on a different molecule and pulls it away from the crystal collection of the sample. So our net equation for this type of process, we start off with our solid solute glucose, and notice on the product side of the equation the formula remains intact, C6H12O6. The big difference here is that on the original side, reactant side, it's in its original pure state solid. Now it is dissolved in water, and we understand that because the new phase is aqueous. This type of attraction could be referred to as a molecule-to-molecule attractions. The molecules of sugar are attracted to molecules of water. So let's take a look at a picture showing a conquer and dividing process. So each little purple hexagon shape represents a sugar molecule such as glucose or sucrose. And notice that as the water molecules come and start pulling the hexagonal shape away from the sugar crystal sample, the hexagonal shape stays intact. It's just that it is separated from the other hexagonal shapes. So method 2, pulling one molecule away from the other, conquer and divide.